Okay, we are going to illustrate all the information that we want to know about covalent bond. Okay, what do we mean by covalent bond? Okay, we have studied before that we take covalent bond in starting from first prep. Okay, what happened to make this kind of bond? Each atom share with its electrons that can't make stability with them. Okay, so we have equal contribution, and mutual sharing means everyone give the same number of electrons, okay, between the two atoms to complete their electronic configurations. We have contribution and mutual sharing of electrons between the two atoms. Why? Each atom to mention or to reaches to what? To the octet state or the stable state to complete its valence shell with electrons and become a stable atom or a stable compound as all. Okay, what we have for examples, we have here hydrogen H2, we have here a kind of organic compound, we called it methane C2H5 or methane C2H4 and ethane C2H6, water H2O, carbon dioxide CO2, chlorine molecule Cl2, nitrogen molecule N2, and acetylene C2H2. Okay, when we see the sharing or contribution of each atom here in hydrogen molecule, we have hydrogen has one electron sharing in the area between the two atoms here, so we can write H two dots above each other or straight line between the two hydrogen atoms. This is the formula that we will write in illustrating the covalent bond. It means that we have here a single or unicovalent bond. Okay, here hydrogen molecule formed by sharing of one electron each. Okay, sharing of electron in a covalent bond, we mean that we have discovered by a scientist called Langmuir refined the Lewis postulates or postulations by updating idea of stationary cuboid arrangement of octet and by introducing the term covalent bond. So we want to illustrate the meaning of Lewis structure or Lewis dot notation for what? For illustrating the formation of covalent bond. Okay, we have here like example. I think it's easy for us to illustrate this today, but when we see the questions, maybe some hard to illustrate the questions. You must know that you have the periodic table, and you must have, as I say in the first term, you must have a drawing for periodic table on your tablet and look at it when you make illustration for the electrons to make what? To make the electronic configuration for the elements. Okay, you didn't need to preserve it in your mind. You have to look at the periodic table and make the electronic configuration. Okay, we have chlorine atom here. Make a sharing, each atom sharing with one electron to reach to the octet state or octet rule for the covalent bond. Okay, here we have 287 and 287, and when a stable state or when making a single covalent bond or unicovalent bond, we have here 288 in each atom. Okay, and each atom contain at the same time the 8 electron or octet state in this case. Okay, make a note here. We have both chlorine atoms attain argon configuration, means that it reaches to the stable state by reaching the octet shell or argon electronic configuration as similar to the inert argon gas. Okay, no metals involve the covalent bond formation. Okay, we have here, to make this stable, remember that it's most stable for the non-metals to reach octet rule easily, but it's hard in the metals, or no metals make a covalent bond. Okay, remember that we say that when illustrating the ionic bond, we are talking about all metals of group 1A and 2A as alkali metal and alkaline earth metal forming an ionic compound. It reaches to stability by forming the ionic bond. But here, no, when we are talking about the covalent bond, no metals can make covalent bond. Okay, why? Okay, think about these questions. You have to study hard, and I will answer you when we solve the questions. Okay, when we are talking about the first one, covalent bond, we have three kinds of covalent bond as mentioned before. We have single, double, and triple, or we can say uni and di and tri covalent bond. Okay, we have different names for them, and every day we have new names for illustrating the bond or for illustrating different items of chemistry. The first one here, we have single bond, and each atom here share with one electron, so the two atoms share one electron pair, and we said that we have a single covalent bond, and we can say the electrons make pair sharing electron. Okay, when we are talking about this, we have to mention in our questions as at the end of chapter the number of electron pair and the number of unpaired electron, number of paired and a number of unpaired electron. So what do we mean by unpaired electrons? The electrons that making the sharing. But paired electron, the electrons as making stability, or the electrons but still in its atom, not making a sharing or not in contribute in what, in the covalent bond. Okay, we have examples. As we have examples for single covalent, we have water, H2O. Okay, oxygen here, it's a more electronegative and take two electrons from the hydrogen atom, so we have here two single covalent bond. We have methane Ch4, that carbon is tetravalent and make a sharing of taking electrons from what, from four hydrogen atom, making contributing of electrons with them. And we have also the main of our covalent bond, we have the ammonia gas, NH3. Nitrogen need 3 electrons, so it make a sharing with 3 electrons with the hydrogen surrounding it. Okay, so we have here a 3 single covalent. In methane we have 4 covalent bonds. In water we have 2 single covalent bond. Okay, so we have a different number of single covalent inside each molecule. Okay, remember well that we are talking about the first type only, single covalent or unicovalent bond. We have here the water, as we have H2O, and also we have the methane form a sharing. We have what? We have 2 electrons needed for the oxygen taking from the 2 hydrogen, and also we need 4 electrons taking from 4 hydrogen, and also nitrogen here formed in ammonia taking 3 hydrogen to make the sharing electrons. Okay, we have the second kind, double covalent or dicovalent. When the two atoms share the 2 pairs of electrons, we have the covalent bond formed between them is called double covalent or dicovalent bond. Okay, what happened to make this kind of bond? We have each atom contribute or make a mutual benefit for giving or sharing with 2 electrons, like what? Like carbon dioxide. Okay, also here we have carbon tetravalent. I think it's main question here. Okay, carbon tetravalent and oxygen divalent. What happened to make the covalent bond here? We have also a kind of very important question. Please study hard for this example. Don't forget this. Okay, here we have oxygen surrounds by 6 electrons and carbon surrounds by 4 electrons. What happened to make what? To make the sharing? Okay, I need only 2 electrons, and I am oxygen and I need 2 electrons only, and I am the other oxygen and I need 2 electrons. So here we have carbon sharing the each one oxygen by 2 electrons from each side. So when we are looking to the bond formation, we have 2 double covalent bond inside the carbon dioxide molecule. I think it's very important example for us. Please study is hard, as it's a main question in our exam. Okay, you think it's too easy. Okay, but some of you don't understand how the bond is formed and what's kind of bond and how it formed. Okay, mention that we have 2 pairs of each atom. Okay, so carbon share with 2 with oxygen and the other oxygen with 2, so we have 2 double covalent bond inside the carbon dioxide. Okay, as we said, we have here the other example, methane. What about methane? Okay, we said methane CH4 and ethane or ethene C2H4. Okay, ethene C2H4, methane CH4 and ethene C2H4 type. Okay, we have here 2 carbon atoms. Okay, each atom need what? Each atom need 4 electrons to complete its outer energy level. So what happened to make what? To make the bond. Okay, we have here different kinds of covalent bond inside this molecule. We have between the carbon atoms, we have a kind of bond, we called it double or dicovalent bond, and between the carbon and the hydrogen, another kind of covalent bond, we called it single covalent bond. Okay, let's illustrate each of them. Okay, here we have hydrogen and carbon, each one we have 4 single covalent bond. We have 4 single covalent bond, and between carbon and the other carbon we have what? We have 2 or 1 double covalent bond. Okay, we have here double covalent bond between carbon and carbon, and each one sharing with 1. We have the number of different bonds. We have the triple. when we contributing or when we combining each atom share or mutual benefit for each one with 3 electron pairs, a triple bond is formed or trivalent bond is formed. We have the main example here. We have the nitrogen, and we taken it before. Nitrogen, each atom share with 3 electrons. Okay, so we can write N triple bond and for illustrating the example for triple bond. We have acetylene C2H2. What happened in example? We have a triple bond between each carbon atom. We have three triple bond, 3 triple bond, and we say between each atom we have a triple bond. And another kind between the carbon and the hydrogen, we have a single covalent. So here we have 1 triple bond and 2 single covalent bond inside acetylene. Inside the acetylene we have 1 triple bond and 1 triple bond between carbon and carbon. So we must mention the place of forming a covalent bond. Okay, so between carbon and carbon we have 1 triple bond and we have 2 single covalent bond between carbon and hydrogen. As we will study in the previous year, in first secondary we have different energy that formed between due to the formation of bond or different kind of bond. Every bond take amount of energy to illustrate the kind of bond formed, as we have in the previous year in thermochemistry. Okay, we have different question. We will start questions. We will start the first question here. Which among the following molecule has a double covalent bond? Okay, I think we must solve the questions a lot for our illustration. Okay, the first one here we have hydrogen H2, second one oxygen O2, nitrogen N2, and fluorine F2. So we have here which one has a double covalent bond. I think it's easy. We have here the oxygen. It has one double covalent bond. One double covalent bond. Okay, let's go to another question. Question number 2 says that a covalent bond is formed in between atoms of metals, non-metals, metals and non-metals, and none. Okay, I think it's easy today to understand this. I think you understand now that this kind of bond formed between what? Formed between all non-metals. Formed between all non-metals regarding the physical state. Okay, we have liquid and gases, but we didn't have any solid that formed what? That formed the covalent bond. Do you think that? Think in this question and I wait for your answers. If we have solid state for a covalent bond or not. Okay, I wish you can answer and I am waiting for your answers for this question. Okay, let's go to another question. Okay, question number 3 says that single, double, triple bonds are formed by the sharing of what respectively? 1, 2, 3 electrons, 2, 4, 4 electron pairs, 1, 2, 3 electron pairs, and 2, 4, 6 electron pairs. Okay, please, we have here different meaning for sharing. Okay, each atom, we said, by sharing of what we want to say, we have here what? 2 right answers. Okay, I think it's very important question today. Okay, I collect some questions very important to you, and inside our lesson today we have a different questions also. Okay, we have here 2 right answers. What happened to illustrate them? If we mention that we have 1 or 2 or 3 electron pairs, so it's a right answer. But we can make a doubling for electron pairs, okay, by increasing the number of molecules that we have. We said that we we can have, like in methane or in ethane, we have what? In ethene we have one double and four single, so we can make a doubling for the bond inside one molecule. We have 2, 4 and 6 electron pairs. Okay, when we are talking about sharing, we said we didn't say the number of electrons, we said the pair that making the share. Okay, please, it's a new language for us in chemistry. Please, you have to mention and to study hard for this kind of question. Okay, let's go to another question. We have here which type of bond is present in N2 molecule. We have single bond, double bond, triple bond, and the last one coordinate covalent bond. Okay, we will mention the new kind of bond in our lesson. We will taking today covalent, and we take new 2 sessions for ionic, and this is the third session illustrating the covalent and its behavior. So we have the coordinate covalent. No, it's we have here in nitrogen, I said we have what? We have triple covalent bond. Okay, let's go into another question. Okay, what we have today exception or limitations for the octet rule. Okay, what do we mean by this kind of rule? Okay, let's mention what we happen to make the limitations of octet rule. Okay, what do we mean by exceptions of octet rule? The incomplete octet of the central atom. What do we mean by this one? In some of the compounds, the number of electrons surrounding the central atom is less than 8. Okay, so it's an exception that we can't reach the octet state or the octet rule in the behavior. This is especially the case with element having less than 4 valence electrons. Okay, we have examples here. We have 3 exceptions today, and we will mention more than exception in our covalent or in the behavior of octet rule. Like what? Like lithium chloride, LiCl, and beryllium hydride, BeH2, and boron tetrachloride, BCl3. Boron trichloride, BCl3. Okay, we have the illustration for each one. Okay, lithium here, we have not reaching the or not illustrating the formation of octet rule. Okay, we have here lithium and chlorine each sharing with 1, and beryllium here with hydrogen forming beryllium hydride sharing with 2, and chlorine here, boron with chlorine sharing each one with 6. Okay, when you are looking at the drawing, so you can see that not each atom surrounds with 8 electrons. Okay, no, not each atom surrounds with 8 electrons. So it's especially the cases with the element has less than 4 valence electron, valence electron. So we have here 1 valence, and here we have 2 valence of beryllium, and here we have boron 3 valence electrons. So it's a special case for the element that has less than 4 valence electron in its outer shell. Okay, we have here the exceptions: lithium, beryllium, and boron. We have 1, 2, and 3 valence electron only. So some other such compound are, we have aluminium chloride, AlCl3, and boron trifluoride, we have boron trifluoride, BF3. Okay, odd electron molecules. We have odd electron molecules. In some molecules, we have some odd number of electrons like nitric oxide, NO, and the nitrogen dioxide. So the octet rule not satisfied for all the atoms. Okay, so we have limitations or exceptions for octet rule in some compounds. Here we have a covalent bond, but it not obey the octet rule, or it make a limitation for it. So we have here nitrogen and oxygen. Okay, it make double covalent bond, but nitrogen need also one electron. So we have here a electron unpaired. We have one electron unpaired in nitrogen atom. Okay, another one. This is the drawing for it. Okay, I will put the electrons in front of you. Okay, you can count them and we will reach the stability. Okay, expanded octet or exceeded octet. Okay, so we have the elements of fourth period of periodic table, starting from the what? Starting from the fourth period, we have in the periodic table for or have apart from NS and NB electrons. So we are going to start a new orbital. We called it D sublevel. Okay, as we mentioned before that we have S, B, D, and F. Okay, starting from the fourth period, we have the contribution of D orbitals. So if we are filling N, S, N, B, and in D, we have N minus 1. So we have, if we have first, or if we have starting from 4, we have 4s, 4b, and 3d. Okay, orbitals in the case of d orbital, and nd orbitals in the case of b orbitals element available for bonding. Okay, all of them can make bonding. So in some of compounds, central atom has more than octet, or we can make many octet, or we can make more than one, as we say. Okay, this is termed as expanded octet, as we have oversaturated by octet. We not make one octet, we can make more than octet between the each central atom and between the branched atom. Also, we can study it in the organic compounds in the third secondary, in illustration of a very hard chapter, very big chapter, chapter 5. I think it's very interesting to me at all. Okay, and we will have the expanded octet, or more than we need for saturation, or we have a different kind of covalent bond inside one molecule. Okay, we have some molecules with exceeded octet, like what? Okay, it's an exception. Please study these examples very hard. Okay, study them very hard. Okay, we have SF6. Okay, what do you think about this drawing? We have here 10 electrons around B orbital or B atom. Okay, we have here 10 electrons. It's a question that gave us in the previous year. We have this exception and we must draw. Okay, you must draw. Okay, we haven't any choice for drawing, you have to draw. Okay, we have here 12 electrons surrounding what? Surrounding B. We have here B and F5, BF5. Okay, another example, we have SF6. Okay, we have 12 electrons around S. Okay, you must draw these examples very well, and you have to mention each example. Okay, another one, we have SO. Here we have SO4H. SO4H. We have here sulfur surrounded by what? 12 electrons. Okay, please study this example very hard. Okay, I think it's very important to you. And we have here this new example that take in the questions. Okay, formal charge or Fs. As we say, we have formal charge of an atom in polyatomic molecule or ion. We said that there is a difference between the number of valence electron of that atom in an isolated or free state and the number of electron assigned to atom in the Lewis structure. Okay, so we have a formal charge, or when you are in a single state, or when you make there is a free or in the free electrons, or when making a bonded inside the Lewis structure. Okay, we have the formula here. Okay, formal charge, so the number of valence electrons in the free atom, what, minus the total number of non-bonding electron, like a lone pair of electrons. So if we need to reach to the formal charge, so we make a difference between the total number of valence electron in the free atom, or before making the bond, and the total number of non-bonding electron here, minus also the half total number of bond pair electrons. To reach the formal charge, we have example here. We have ozone molecule. By drawing its Lewis structure, we have here 1, 2 and 3 electrons. Okay, formal charge for the first oxygen. Here we have equal, we said the rule, we have the total number of electrons 6, total number of electron in the free atom 6, minus what, pair electron 4, or lone pair of electron 4, minus also have the number of what, of bonded, we have here 4, that each atom, or in here we have 4 electrons, so have its number. So 6 minus 4 equal 2, and half time 4 equal 2, so 2 minus 2 equal what, equal 0. Okay, so the formal charge here equals 0, so it hasn't any charge extra on the what, on the first oxygen. So we're going to the second oxygen. The formal charge of it equal, if we making counting to the electrons here, we have also what, 6, minus unpaired we have 2, minus have, we have bonded here 2, 2, 2, so we have 6, half times 6 equals 3, 6 minus 2 at here equals 3, 3 minus 3 equal, we have here 6 minus 2 equal 4, so we have in the plus, or in the positive, we have plus 1, so we have here increases in the charge by, or the formal charge by 1. The other one, the third one, let's going to it. Okay, do you think what here, the charge increases from one atom to the other? Okay, we will continue. We have 6 electrons that surrounding the oxygen as whole in the formal state or in the normal state, but minus what, we have here 6 electrons surrounding it unpaired. Okay, minus what, minus 1, half time 1, half time 2 making a bond, so we have here 2, half time 2, it means 1, as I said, 6 minus 6 equals 0, so we have minus 1 as the last what? As the last oxygen atom in the ozone molecule. Okay, so to draw it, we have what? We have 0 electrons, or formal charge here 0 means that all the first oxygen atom make or reaches to the octet state. But we have plus 1, so it means that plus 1 that we have one unburned what? Unburned electron. And here we have one what? One burned, and the result one negative here, that we have one negative one, that we have one burned. Okay, and the rest is unburned. Okay, so we can write the positive charge on here on oxygen atom, and we can on the other atom. So we have the resonance on Lewis structure for the ozone. If we write it, we can write O and O plus and O negative for the Lewis structure of ozone. Okay, also we can reserve it or make a resonance for it as the electrons transfer. We can write, or as make isomer. Isomer means making a converse to it, so we can write here negative, positive, and dots, or making, we can call it a resonance. Okay, we can get it or get the other one, so the two reaches we can say they are resonance, or resonating structure 1 and resonating structure 2. Okay, so each one we say contributing structure or conical structure or conical form for what? For what? For the oxygen. We have here the oxygen, and we said that we have resonance hybrid 3, resonance hybrid 3, as the 3 atoms what? Making the stability or reaches, making one of them as resonance hybrid 3. Okay, it's unstable compound. Here we have the more stable or more energy, as each atom needed or have more energy, but when we reaches the resonance hybrid, we have less energy and more stable reaches to the Lewis structure of the ozone. This energy loss is called resonance energy. Okay, we have in, so to mention that we have the ozone molecule, it can lose electron or lose atom easily by what? By any kind of rays. Okay, this is about very important question here about the ozone gas. Okay, we have another example, carbon or carbonate ion CO3 negative 2. We have here carbon in the middle, and we surrounded by 3 oxygen atom. Okay, we said that we have oxygen, it is the main behavior or main unbehavior in the, or abnormal in the behavior, so we can write negative 2 here, and formal charge on carbon atom equal, we have carbon surrounded as end by tetravalent, so we have 4 minus. Okay, 4 minus what? 4 minus, if we mention that make a bond, we have all make a bond, so minus 0, and minus half time all make a double bond, so we have here 8, half time 8 equal 4, 4 minus 4 equals 0. This is for carbon atom. Okay, formal charge on double bonded oxygen atom. Okay, here we have, this is the double bonded atom oxygen, so we have here 6 atom that in the valence shell, minus 4 that unburned, minus half time that time, here we have 4, 2 times 2, here we have 4, so half time 4 equal 2, 6 times 4 equal 2, So we have 2 minus 2 equal also 0. The formal charge on the oxygen of the single bond, single bonded oxygen, we have two single bonded oxygen. We have 6 minus what? 6 minus 6 minus half time 4 or half time 2, as we have here 2 electrons only. So half time 2 equal 1, 6 minus 6 equals 0, so we have negative 1. And each one here we have negative on this one and negative on this one, and also on the all the group we have right negative 2. We have another example, nitrite. Nitrite NO2 negative. If we write or drawing the NO2, the first one here in the middle we have nitrogen, and nitrogen surrounded by 5. We have here at end we write oxygen, oxygen surrounded by 6. So oxygen surrounded by 6 and 2 here have the bond, and nitrogen here have 2 and 3 making bonds with other. We have here 4 and 4 reaches the octet, and mention here the formal charge of nitrogen atom in the middle equal, we have what? We have 5 minus what? Minus 2 ampered minus half time. Here we have 2 4 6 minus 6 half time 6 equals 3. 5 minus 3 equals 3, so the net charge will be, or the formal charge equals 0. Okay, formal charge on double bonded, here we have double bonded oxygen equal, we have oxygen surrounded by 6. 6 minus, we have what? Ampered 4. 6 minus 4. Also we have 4 half time 4. Okay, so half time 4 equal 2. 6 minus 4 equal 2. 2 minus 2 equals 0. The last one here, formal charge or single charge, single bonded oxygen atom, okay, equal, we have 6 minus what? 6 minus, we have 2 4 6. 6 minus 6 time minus half time 2. Okay, so we have here 1. 6 minus 6 equal 0, and it will give negative 1. So the charge, netted charge written on the nitrite ion will be negative or negative 1, as we say we don't write the number 1. Okay, I think it's a very hard part in our lesson, but we need to mention that we have a different question. Question number 1 says that the number of valence electron of B in BF5 molecule, we have 5, 10, or 8 and 15. Okay, we have here BF5, we said we have here exception that we have 10 electrons, so we have here 10 electrons of valence electron here in what? In BF molecule, BF5 molecule, or boron pentafluoride, phosphorus pentafluoride, phosphorus pentafluoride, we have here valence electron of 10 electrons. Another question here, we have number of valence electron on sulfur in H2SO4 sulfuric acid or sulfuric molecule, we have 6, 16, 10 and 12. What is the number of valence electrons in on sulfur? As we said, we have here 4 and we have here 2, so we have multiplying 6, we have 6 electrons, multiplying 2, we have 12 valence electron surrounding sulfur atom in H2SO4 molecule. Another question, formal charge on nitrogen in nitrite ion. Okay, if we said nitrite ion without any thinking, nitrite ion NO2 negative, so the net charge or the formal charge will be what? Will be 0 on it, will be 0 on the nitrogen atom, will be 0 on the nitrogen atom, but on one of the two oxygen atom will be negative 1. One of them 0 and the other will be -1. But on nitrogen, the net charge, as we making illustration for this formal charge, will be equal 0. Okay, we have question number 4. Formal charge on nitrogen in NH4 plus. If we have what? We have ammonium ion, NH4 ion plus. It's very important formula in our chemistry. We have +1 and -1, 0 and -3. I think it's easy to know that we have extra number of hydrogen, and it belongs to what? Belongs to nitrogen as all. We have +1 on the nitrogen, not on the hydrogen. Okay, I hope you enjoy this part of question today. Thank you for joining. Please study hard for each example today. I think you must study from this session very hard. Hope you enjoy. I'm waiting for your questions. Please, if you have any questions, leave them below the video, and I'm waiting for each question every time. Thank you for joining.